extends version 2. It is extending version 2. That means it have the features of both version 1 and version 2. And I said collection. So it is a string type, and it has some enumerations like this. And I'm creating a class, so TypeScript. So this extends version 3. This extends version 3, and it is having so version and is a string type, and its name is TypeScript 3.8 like this. Now here this represents a multi-level inheritance. In a multi-level inheritance, a derived class can be extended by another class. That derived class can be extended by another class. So it represents a multi-level hierarchy. So finally, we will create TypeScript as an object is equal to new TypeScript. And through this TypeScript class, we can access all the members and print all the details. That means we are using console.log, and we can access all the details. So language. So what's the language is $. So we are defining as a version TypeScript dot version. We can access that version, which is the member of the TypeScript. And features. So here I am defining features. In the next line, features. I'm using here the features. So what are the features? So /n, and these are the features. So features TypeScript dot parameters, and in the next line we have a $TypeScript dot functions, and in the next line we have TypeScript dot collections. So all these details are defined at one place. That means through one object we can access the members of all classes. This represents a simple multi-level hierarchy. So let's go to the inheritance, compile and run this. Yeah. So we are compiling inheritance. And this is representing a multi-level inheritance. So here, so node inheritance.js, it can print all the details. So language TypeScript, and it features REST parameters, anonymous functions, enumerations. So through one object, you can access the members of all classes. This is what generally the exhibition of multiple inheritance, multi-level inheritance. So already we know this, just I given in terms of classes. So inheritance is a mechanism of code extensibility as well as code reusability. It extends the code and it allows to reuse the code by defining relationship between the classes. Without relationship between the classes, accessing the members of one class in another class can be done by using a technique called aggregation. That is one reusability. Another reusability through inheritance by creating relationship between the class. So this is called is in relation, is a relation, and aggregation is called has a relation, has a relation. And what is difference? We saw with examples how we can handle, and what kind of inheritance are supported for classes. So multi-level inheritance, this is an example for multi-level inheritance. And why multiple inheritance is supported for interfaces and not for classes. It is supported for interfaces because interfaces doesn't have constructors. And if there are no constructors, then usually if there are no constructors, then there will be no deadlocks in constructors. You don't have any issue of prioritizing the constructor calling if there are multiple superclasses, right? So that is the problem. Now here one more point is you might have observed it and you remembered it. So because that is also comes like a question, like how do we call? So that comes like a question. I hope you have observed that. How to call a superclass constructor. Superclass constructor. Class constructor. Constructor. In derived class. In derived class. How to call a superclass constructor in derived class. That is the basic thing you might have observed. So for that, what you have to do is, so by using super, so by using super and the call of constructor. That's how we have to call the superclass constructor, right? Yes. So in the derived method, you have to define by using super. So you might have observed that, and it is very important also. So how do we call a superclass constructor in derived class? It is mandatory, especially when you are using explicit constructors. When you are using explicit constructors in inheritance, then if there is a superclass constructor and you have a derived class constructor, without calling the superclass constructor, it will not allow you to configure derived class constructor. So it's mandatory to define it. It's mandatory to define it, right? That is one major point you need to understand. Okay. So due to this, one important technique is there. One important point here is there. Suppose if you are learning other programming languages, which are OOP languages, usually suppose in other OOP languages, suppose I am creating like this. Suppose just syntax I'm giving roughly. This is base class object. So this is an object. Of a base class type. That means it is an object of superclass type. Is using the memory of derived class. It is using the memory of derived class. Superclass object